This conference will now be recorded.
I had just started discussing like yesterday polymorphism. Anyhow, we'll take it as a fresh topic today and we'll discuss from the very beginning. You know, right? The general meaning of polymorphism is poly means many. Excuse me. Morphism means forms. So what do you mean by this? Same name or same method. Usually polymorphism is applicable for methods. It is applicable for methods. So what is this here? It is nothing but same method represented in many forms, and we call it as nothing but that is known as a polymorphism. And you know, friends, okay, you know, friends, here when you talk about polymorphism, we have two types of polymorphism. So how many types are there? We have two types. So one is method overloading. Okay, the other one is method overriding. Of course, overriding is applicable for, we can take it as two types. We can divide it into two types. Not we, the Scala people are Java people are C++ people are, you know, all these people. One is overloading and overriding. Actually, we can again classify this polymorphism like this. How we can call it as compile time polymorphism. That is one type of polymorphism. Compile time polymorphism. The second one is a runtime polymorphism. Runtime polymorphism. So to explain, or when you ask me what is compile time polymorphism, is definitely compile time polymorphism is implemented with the overloading. And runtime polymorphism, we see that in overriding. So these are the two different things which implements compile time polymorphism as well as runtime polymorphism. Got it right? Now the question is, what is compile time? What is runtime? Okay, it is a simple point. First, I'll talk about one important thing: method resolution. Okay, or method binding. I'll talk about something called method binding first. What is method binding? It is a simple example. It is a simple thing. All of you know this. Everyone in this session know that because we have done functional programming. Scala functional programming is done. We are in object-oriented programming. When we were in Scala functional programming, we had a discussion like how functions work, how they were called, how we pass parameters. We had a lot of discussion at that time. But now it is not difficult to discuss this method binding here with a simple example. Might be okay. We'll directly understand it in Notepad itself. Suppose I have a method like this, folks. Okay, I have a method something like def m1. Now, when I declare a method, you know, right? We have to call this. If this method should be executed, we must call this. Correct. Then how do you call it? By using some caller. So something like m1 or something like m1 1 command, something like m1 3 4 like this. Okay. So now the question is, I think all of you are clear, right? Hope you are able to hear me. We don't have any audio issues, all that, right? Okay. Thank you. Okay. Now if you see this method binding here. Now we have a method here, m1, and you can, if you want, you can provide a the complete what is that the prototype. Okay, and then you can check this. Now if you look at this, what is that here? This method m1 is there. which is a default method. Now here we are having different colors. Now if I ask you a question, without any doubt, everybody will answer this. My question is simple. Which color is going to call this method? Now we have three colors here, M1 with 2 parameters and M1 with 3, 4, like otherwise 3 parameters. Now, which color is going to make a call to this method among these 3 colors? Which one? The first one, second one, or third one? When you have a method, you should call that method, right? Method has to be called, then only it gets executed. And if method should be called, then we do that with a color. And here we have multiple colors here. Now the question is, which color is going to make a call to this method? That is the question. I think everybody can answer this question, correct? Right or wrong? Yes, all of you know this. Definitely, this M1, the first one, is the caller, which is going to make a call to this method. By looking at the method, by looking at the caller, you are able to decide which caller is going to call which method. Now M1 is there, then M1 is called by this caller. Suppose this time I give 2 parameters like this, int comma a colon b colon submit like this. Then even now, I know everyone in this session will answer this. This time the caller is second one. Suppose if I take one more integer parameter, then you say the third caller is going to be binding this method. Means what's happening here, method binding means it's very simple. When which caller is going to call which method? Now this calling, you have a caller here and you have a method here. Which caller is mapped to which method is nothing but we call it as method binding. It's like a marriage proposal, right? You send a photo to a girl or a boy. If it is girl, she will send to boy. If it is boy, he will send to girl. Now both has the photos. You go to a match, that is a proposal thing. You go to the girl's house or boy's house. Usually in Indian custom, girls don't come to boys' house except in Hollywood. Okay. The point is, when the boy go to the girl house, what first he will do? If girl is a method and if boy is a caller, first he will check the photo. He has a photo in the pocket or he has that photo in the mind. Now he will compare that the image of the girl with the physical girl which is there in the who is there in the house. Then if it is matching, then okay, it's fine. The match will be successful. Suppose the girl has is not matching here, then automatically what happens, even it is applicable for boy as well. As I'm just only trying to make you understand the binding concept. If both are fine, if what is that if boy is able to map that with the image of the girl, which is who is physically present, then automatically binding, that is marriage, will happen. Otherwise what happens? Nothing happens. Compilation error. What is that? What is the compilation error? It will say the method has multiple parameters, but the actual caller is not doing that like that. So the point is simple. Binding is a simple concept. What is that? The process of mapping a method to an appropriate caller. That's nothing but binding here. And usually this binding happens in two ways. One, in the first case, it happens in two ways, isn't it? In the first case, it happens with compiler, and in the second case, your JVM will take care of that. Binding can happen in two ways here, folks. What is the first approach? In the first case, binding is done by the compiler itself. That is called compile time polymorphism. If method binding is done by the compiler at the time of compiling the program itself, we call it as compile time polymorphism. If method binding is done by JVM at the time of executing the program, we call it as a runtime polymorphism. It's like love marriage and arranged marriage. Got it right? Compile time polymorphism is more or less love marriage. Correct. Runtime polymorphism is arranged marriage. Okay. So anyhow, why I just compare it with love marriage means compile time polymorphism, because you both will have an understanding before marriage itself. Okay, that's why I just choose that example. Runtime polymorphism means in this arranged marriage, both the partners will get understanding after marriage. That is runtime. Means JVM will know which method has to map with what color at the time of executing program. That is runtime polymorphism. Whereas compile time polymorphism, compiler will do the binding at the time of compiling program itself, not at the time of executing. JVM just execute it. Like when somebody love each other and propose it to parents, somehow parents has to agree. Otherwise, compilation error will come. That is a different story. Okay, same thing here. Once binding is done by the compiler, JVM simply execute it. That's all. So this is simple idea about method binding and compile time polymorphism and runtime polymorphism. You got clarity here? What is method binding? It's a simple approach where the mapping of a method to its appropriate or to its specific color is nothing but we call it as a method binding. So what is method binding? It's a simple thing. The process of mapping. These are all simple things, sir. But until we just listen somewhere or learn or read it somewhere, that doesn't strike. That's all. Nothing more than that. The process of mapping a method call to its appropriate method or vice versa. A method call to its appropriate. Usually it starts with method call. Usually what happens when a method makes a call, then the method gets executed. So mapping happens from caller to method. Mapping a method call to its appropriate method or function, whatever it is. We can say it as function as well. Is called, what is that, folks? We call this as method binding. Got it right? Is called method binding, or you can say function binding. Okay, by default, the binding exists is compile type. Okay, when you use any function, the default binding happens is compile time binding, because compiler itself will automatically do the binding of method call to the method at the time of compilation itself. So most of the time the binding happens is compile time binding, because compiler takes care. Runtime binding happens only in certain cases, only when there is a concept of method overriding, that too when we have this object oriented programming. Only in such case we have this runtime binding. Okay, that is also called dynamic binding. If you ask me, any other name, alternative name for that, we can call it as a dynamic binding. Got that point, right? You might see this word many times in many different textbooks. Okay, dynamic binding. It's nothing but binding of a method at the time of executing a program is nothing but a dynamic binding. Okay. So same thing here. Now we have seen an example here. What is that? Here we have observed, and you know all this, right? Who can answer this? Who cannot answer this? Sorry, who cannot answer this? Because all of you are, matured now. You got your good background of all this now. Okay, so I don't think this is difficult to understand. Now after that, compile time polymorphism. What is compile time polymorphism? If method binding happens, what is that? If method binding happens at the time of when is it at the time of compiling, or is it at the time of executing? When this happens? If method binding happens at the time of compiling a program, and who will do that? Obviously, who will do that? Your compiler will do that, sir, at the time of compiling a program. Okay, program is compile time polymorphism, or you can just say is known as a compile time polymorphism. I just put it as CTP just to make it fast. Got it right? That's it. That is one important thing. Then what is dynamic binding? Same thing, but the only difference is if method binding happens at the time of executing a program. Maybe if you ask me, can you show us some examples? No doubt. We will see this with examples. By default, no compile time polymorphism exists. So far, what are the programs you have done? By default, it is a compile time polymorphism, because method binding happens usually at the time of compiling program, unless we have this overriding thing. Then dynamic binding happens. Okay, our runtime polymorphism exists. Maybe if you ask me, could you show us some examples? Yes, definitely. We are going to see both with the different concepts here. We are going to learn compile time polymorphism with the method overloading and runtime polymorphism with the method overriding or variable overriding. We can see that with that. Okay, now coming back to the runtime polymorphism, how do you define it? If method binding happens at the time of executing a program, is that when this happens? It happens at the time of not compiling, at the time of executing a program. Excuse me. Then we call it as what is that a runtime polymorphism. And you can also call, there are different names for this. We can call this as dynamic binding. What is that? Other names for this is this is also called dynamic binding. Okay, and also you can say this another name for this is a dynamic method dispatch. People also call with other names. You can see all this is that this vocabulary in the different websites or textbooks. So dynamic method dispatch. Got it right? PATCH means your method will be called only at the time when you start executing by the JVM. Until that, JVM even doesn't know which method has to be mapped with the which color, or which color has to be mapped with which method. So at runtime, JVM decides which color has to be mapped with which method. That is this runtime polymorphism, or this dynamic binding, or this dynamic method dispatch. Got it right then? So that's simple, sir. Probably by now you would have got some understanding, clear understanding here. What is binding, or what is method binding, or what is compile time polymorphism, what is runtime polymorphism. Now, first we'll talk about compile time. We'll take an example for compile time polymorphism. So compile time polymorphism. Usually, compile time polymorphism is implemented with the overloading, but by default, the polymorphism exists is with methods is compile time. Even if you don't implement overloading, still we have that that compiler is the one which do this binding. So there is nothing much to get confused here. This is a simple straightforward. But to get a better idea, like how compiler decides this binding, just to get more better understanding, a deeper understanding, we are understanding that with a concept called overload. This programming people, language people proposed as overloading to understand how this compiler will do this binding with this polymorphism. Okay, so overloading is that. We'll go back to overriding after this. First, let's understand what is overriding. What are the rules we have to follow while doing overloading, while overloading methods, and how to call these methods, and how this binding happens. Now we are going to understand. One thing I would like to remind you, we had already discussed overloading, at least to some level. You remember, right? We have discussed constructors. While discussing constructors, we had a very detailed discussion, like about the constructor overloading, if you remember. But then I told you we'll get more understanding for overloading in the methods, with the method in the polymorphism. So we are going to talk about it. Okay. So what is overloading? Now let's understand the definition. It's not difficult. It's very simple thing, because we are all familiar with methods. Declaring a method, I'm just declaring a method with same name, but with different parameters. Different parameters is nothing but overloading, or we can call it as method overloading otherwise. So what do we call it as a method overloading? That is one thing. Okay. So what is method overloading? Same method with different parameters. But here we have to follow two rules, two things. One, either the data type should change. When you overload a method, you should follow any one of these two rules. First rule, either the data type should change or either number of parameters should change. Got it right? When you are going to have a method with different parameters, how this difference happens? Simple. Either what you have to do, the data type of parameters should change from one method to another method. The data type of parameter should differ or should change. Anything is fine, sir. Should change from one method to another method. This is only for overloaded methods. Okay, one method to another method. That is one thing. Second thing is, otherwise either number of parameters should change. If you don't want to change data type, at least increase the number of parameters. Got it right? So either number of parameters should change. Are you following, sir? So this is the idea about overloading, sir. We'll see a few examples. And also if any pros and cons are there, we'll discuss that and close this topic. Okay, now let us take a small program. We don't need something big program now to understand overloading. And we'll just get an idea, like, why do we need overloading? One more important. What is the necessity of overloading? When do we go for overloading? In which cases we prefer overloading? So even you need to get an idea about that. No, because when you do something, we should know why we are doing it. That is important. And when we are doing it, how we are doing it. These are very important things in programming. I hope most of you, all of you know that. I'm taking a class A1 here. Just simple methods. We don't need to take some fancy methods here. We can just take some simple methods, def m1. Maybe usually, when you overload a method, most of the time, methods are parameterized methods. They are not defaults. But here for our understanding, we can show that with the default and parameterized. But when you go to the real use cases, real-time project, in most of the cases, when you overload a method has parameters. Okay, got it right? So I am just taking a simple example, M1 with I'm overloading M1 with different parameters. Or assume that I am doing an addition. That's better. Now I can do addition in different ways. I can do addition on integers. I can do addition on decimals. Means I can take addition on I can perform addition on integer values or integers, or I can perform addition on float values, or I can perform addition on double values. Usually these are the most preferred parameters people use in the real-time use cases. Of course, sometimes we have long and short or byte, but integer, float and decimal, float and double are most used types when you are doing this overloading. I will show you. We don't need to worry about it. So now if you see, I'm taking sum of two numbers here, and I'm overloading that add method here. You can see here, the program is not difficult for any one of us here because all of you know how to find addition. This is very simple program for all of you. So what is the point here? Take add method with integer parameters. Now you return that result because whenever we implement a method with parameters and it has some business logic inside that, returning that result is one of the good programming practices. Okay, because we implement methods. Why do we implement methods? Means it will implement some business logic and that result is given to us. So to have that result, we implement methods. Okay, so I just want to implement some of these two numbers and return it. And right, in Scala, you don't need to use any return statement. You can just implement that logic or that and just simply declare it by automatically that is returned to the caller. Okay, that is one thing. Second function. Now another one. Okay, this is method one. Another method. This time I had implemented this method with integer parameters. Now I am going to implement same method with the float parameters. You see here I am taking float, and in the second case also I am taking float here. I told you typecasting concept. Do you remember, right? We had a discussion about typecasting. What is it? We can do downcasting automatically, but we cannot go for upcasting automatically. Upcasting is not possible implicitly. Downcasting is possible implicitly. You remember that, right? So here the parameters are float and you are doing addition of float values or float variables. Then the return type integer, right? Integer means you are returning integer means this is downcasting. You are trying to decrease the level of float to int here. It's not possible. So you either change this or we have to change other part. But for now, as per my requirement, as I am doing addition of two float numbers, I am changing my return type here. Okay, float. Then the third one, if you want, by now this is overloading, sir. When you declare two methods with same name and different parameters, that itself tells the concept of what overloading here. Now, what I'm doing now, I'm taking one more method. You see here, I'm taking one more method with double parameters. Maybe see, two methods are enough to understand method overloading. Overloading means declaring same method with the different parameters. So that the first two methods itself gives us a clarity. Okay, overloading means this. I have same name for two methods here. Add and add is same here. And we have changed the parameters. In the first method, we have integer parameters. In the second method, I have float parameters. Immediately, some of you might ask me, sir, even in the second method, the parameter should be integer, sir. Then you increase one more parameter, two more parameters, three more parameters, increase parameters if the type should be same. But of course, when you go to the real implementation, nothing is in your hands. You get a requirement, you have to implement a code as per the requirement. Anyhow, we are working people, we know that. So this here at this level, we can play with whatever in whichever the way we like. Okay. But now here change this again. Let's make it double, comma, b colon double. Got it right? Huh? So, and again, the issue now. Why it's showing error here? Because the return type should be modified. The float is a lesser than double. The level of float is a bit lesser than or smaller than double. So now what is that I should do now? This is downcasting again. And downcasting is not implicitly supported. Explicitly, you can do whatever you want. You can convert this whole result to float. No, then you can keep this as it is. There are different ways. But now, just to make it simple, I am just taking here double. This is overloading. Usually, no, this overloading is the most used concept in a real-time project. Okay, why? Because the advantage. Let's talk about the advantage from a real usage. The advantage of overloading is for one method I can pass different parameters. Might be while calling you don't call different methods. You might implement different methods in the class, but at the time of calling, you see here you create an object for a1. So var space some a equal to new a1. Okay, a dot add. Now here when you are calling here, you see, sir, it doesn't feel we don't feel like we are calling different methods, but we feel like we are calling just one method, but we might pass different values. Suppose you see, sir, I am passing integer parameters to this. Again, see this to the same method, I might pass float parameters, something like 1.0 f, okay, or 2.0 f. Maybe for just for you can keep it like that, not an issue. Again, you can see, sir, 10.0 comma 20.0. Can you see this, sir? Now, if you see this, for us at the caller level, when a user is making a call to the method, he doesn't feel like he is calling three different methods. He just feel like he's calling one method. Got it right, sir? Now, what is the advantage of overloading? Sometimes when you are implementing, implementing some requirement, we need methods which performs implementation on integers or sometimes on decimals or sometimes on floats, like that. So the advantage of overloading is to the same method we can pass different types of values and we can work accordingly. So that is the advantage. One of the very useful concept in object oriented programming is overloading. Suppose you see, sir, if you want to get more clarity, you see, I'm just showing you API of a Java class, where we can see a lot of overloading happens in that class. I'll just show you now. So here, if you see Java P means help, sir. If you want any help in Java, we should use this Java P, java.lang. You can see a math class. Sir, remember, when you are learning Scala, maybe you can exclusively learn Scala, no issues. Once you know Scala, you can backtrack Java. But you can go to Java and you can understand Java without any difficulty there. Okay, because if you learn one language, you know, right? The other language is simple. Now, I am going to Java. I am saying java.lang.math here. When I say this, look at these methods in math class. Can you see? These are all real. You can consider this as a real-time project, because we use these methods number of times in our programs in a real-time project, the one which we develop. Now, if you see, sir, here there are so many methods which are overloaded. You can see min is implemented for 2 times, and this min method takes 2 different types of parameters. You can see it is taking integer parameters, long parameters. You can see, sir, 4 times, not even 2 times. I'm sorry, I didn't observe the remaining 2. You can see min is overloaded for how many times? 4 times. And you can see here it is declared with integer parameters, long parameters, float parameters, double parameters. Means what? They are giving an opportunity to the developer to use any one of these methods as per the developer requirement. So the advantage is not every time I'll find minimum of integers. Sometimes we need to find minimum of decimals as well. Sometimes we need to find minimum of a long as well, or float as well, double as well, or integer. So what is this overloading doing? It is giving us an opportunity to use a method whichever is going to be useful to the requirement. Whichever suit the requirement, that is going to be used by the developer. Got it, right? So this is the greatest advantage of overloading here. So program is not difficult here, sir. Understanding why we are implementing is important. Okay, let me run this. Okay. Now you know, right, sir? We have methods here and we have callers here. Now you can answer this question. This caller is going to be binded with which method? Your compiler is going to do binding of this caller to which method, sir? No doubt to the first method. What your compiler will do? It will check first the name of the method, and second it will check the type of the parameters. Third, it will check number of parameters. See, that's what compiler do. It will see all these 3 characteristics. What is that? Whether the method name is matching, whether the data types are matching, whether the number of parameters are matching. If all these 3 are matching, then automatically binding happens, like in a marriage proposal also. If the girl is satisfied with all the requirements of a boy package, first she will see the package of the boy, second the height of the boy, third the fairness of the boy, and the face features, and other one is the goodness. Okay, then if all these are matching, binding happens, right? Same thing. Got it, right? Here also, when you are doing a method binding, what all your compiler is going to check, have an idea on this as well. Okay, now you know this is going to be binding with this caller is going to get binding with the first method. This is going to be binding with the second method. This is going to be binding with the third method. How this happens? It depends on parameter types, sir. It depends on what? Parameter types and number of parameters and method name. All these 3 is important here. Okay, that's simple idea. Now when you run this code, you can see, sir, you get this. Of course, I am not seeing any result here. You know why? Because these methods are returning results. Either you have to initialize that results to some local variables and print it, or you can directly pass this to a print statement. You know one thing, when a method return a value, then you can directly pass it to a print statement. But if it is not returning, passing to a print statement is not that good idea. It's actually, because if it doesn't return any value, there is no use of passing a caller directly to a print. But for now, what I can do, There are different ways. One is passing to the print because this is our area, but in a real use case they don't print it, but they will preserve that result into some local variable, something like we val1 equal to something like this. And second time again they will say var space val2 equal to, and third time they will say var space val3 equal to. Or you can make it as val also. If you want, you can put it as val also. There is nothing problem for us. What do you do, sir? Just print these variables, you get the results. So println of val1. Now print the remaining two, val2, val3. Okay, just run it. You got it right, sir? 3 is integer output coming from method with integer parameters. 3.0 is the output coming from float parameters, and 30 is coming from it is the output coming from with the double parameters, method with double parameters. Got it right? So this is simple idea about overloading. So what is the greatest advantage of overloading? So use of overloading. Why do we need overloading? Okay, it's simple. To the same method, to one method we can pass to one method. What is that? We can pass different values. Method we can pass different values, so that the developer can use this method as per his convenience, his or her convenience. Okay, so we can pass different values. Not every time we deal with integers, sir. Sometimes we have decimal, sometimes it might be float, sometimes the integers again might be long. So to handle all these scenarios, this overloading is going to be very useful for us, sir. You got it right? And now quickly test this program, sir. This is, we are done with overloading. Maybe I will add one more point to this and close this overloading and switch to the next topic, that is overriding. And before that, what do you do? Just test it, sir. I think you are asking me to paste it, right? Sometimes okay, I don't think we can copy and paste all this. Please test this code. I will paste. Okay. You can see that you can take the notes, sir, just for your notes pairing purpose. Anyhow, I told you, right? I will put it in my GitHub so that it will have access to everyone. Okay. Probably we missed last print statements. Okay, sir. Please test it. Take 2 minutes time. Test it. Then we will move to the. I will add one more important point here. Might sometimes, I see people asking questions like, as we discussed, right? Method name is same, but parameters are different. Sometimes students ask me a question, or the learners ask me a question. Sir, uh, if we just change only return type and keep the parameters as is, then still is that making difference or not? That is the question. Can we consider it as a different prototype or different method signature, or is there anything else? That is another important point. I will conclude that once you finish testing. Okay, please. Once you are done, just please confirm. If you want couple of use cases, even I can give you that. Would you like to solve few overloading programs? Once you finish this, I will give the overloading. One or two use cases, you can solve them yourself and you can apply that overloading thing by yourself. From here, I think we can take few use cases and you can start implementing it, sir. So again, earlier, because the most of the things we have done are more of conceptual, we didn't get an opportunity to take assignments. But now you can start doing, start solving few of these assignments now. I hope you are done with this program, right? Once you are done, I suggest you can solve this problem as well for overloading. Okay, write a program to find as we have seen, right, minimum of two numbers. Okay, using method overloading. And I was telling something to all of you. Are you done with this problem, sir? Did you finish testing this? Others, what about others, sir? Shall we discuss? Okay. Now you see there is one thing, sometimes people have this question. What is that? Now this is method signature. The whole heading, usually technically we can call it as signature of a method. This method name and parameters, okay, and return type. We can call this as signature. Now in this method signature, usually in overloading, we consider method name and parameters. Return type doesn't have any role in this. It doesn't decide the signature. It doesn't have any role in this overloading. Suppose you might have same parameters for three methods. If you just change return type, it doesn't have any impacts there. Still you have a compilation error. Suppose you see here, this is the question people keep asking. Okay, suppose I have int here for these two methods. Okay, but my return types are different here. You can see the first one has int, second one has float. Now these are different, sir, but still I am seeing an error. Why? As soon as I change this data types, immediately I'm seeing an error because this is redeclaration of a method. When two methods are same, it has same name, okay, same parameters, then it is a redeclaration. And just changing return type doesn't make it a different method. Got it, right? This is one important point you have to keep in mind. Okay, so this is one important observation. Got it? Hope this is clear. So just now you can go back to your business, sir. What is that? Now you solve this minimum of three numbers by implementing overloading. Maybe you can take four different types of parameters. You can test for min of int parameters, min of long, min of float, min of double. You can see that even in the API of Java. One important thing, sir, you use in a real time, Scala project, in a real time big data projects. Most of the cases, you can directly use most of the Java code in the Scala. And you might be we don't use Scala in Java, but that Java thing we can directly use. Most of the libraries, most of the declarations we can bring as it is and put it in Java in Scala. That's what we call interoperability. We had discussed this in the very beginning of Scala. Got it right? So that makes your Scala much more robust, more stronger. It makes Scala Hulk. Okay, right? That is the point here. So why don't you try this program, sir? Minimum of two numbers using method overloading. From here onwards, we have a lot of use cases. It's interesting because when you solve problems, it will be little interesting for us. You can take your time. There is no hurry here. Take your time, implement it. You implement at least some 2 or 3 different minimum methods, overload at least with the 3 different parameters. Min with integers, min with long. How do you differentiate long from integer? That is another question for you. Okay, let me see how you are going to handle it. How do you differentiate integer from long? There is actually some difference. If you don't remember, I will remind you, okay? Or if you don't know, we will discuss. Nothing to worry. Please, uh, there is some noise coming. Please mute your machine, okay? Okay, like this. Now you implement a code. I didn't give long parameters because I want to know like how you are going to test it if it is long. Yeah. It's confirm once you are done, then no, you take 1 or 2 more minutes. Then I will show you how to implement minimum. Anyhow, you know, right? How to find minimum of 2 numbers. That's not difficult at all. Okay, guys. I'm just showing you how to implement this. I know every one of you would have been done this. So here, just I'm changing the name here. Min. Here also just min and min. For long, I'm taking one more copy of method, copying and pasting, and change this to now change the data types. What is that? Change these parameters as a long here and here also long. Okay, and then we'll implement code again. We'll change the logic one again. And here float is fine and double is fine. Now change this return type to long here. The logic is same for all the methods. There is not don't have big difference in logic. A less than B. You don't need to do anything. Just return that A. We need minimum of 2 numbers, right? Else What do you have to do? Just return that B here. Okay, sorry. Sometimes this is it. We are done. Copy and paste the same logic in all the methods. That's all. This is how to find smallest of two numbers or minimum of two numbers. What did I do is, you have done this in the very beginning. I know even you would have done this. Just copy and paste this. So that's also, this is idea about implementing minimum of two numbers with different parameters. We have altogether 4 different signatures with same name, of course. So we have min with integer parameters, with long parameters, with float parameters, with double parameters. Now let us test it. Okay, simply you come here. You just, what you do is call these methods min of 1 comma 2, and then min of, if it is a long value, how you are going to take it? Okay, leave these parameters as is. So min of float parameters, min of double parameters, and to test the other one, what is that long parameter? Can somebody mute your machine? Okay. So here the only change I have to do, if I want to make this as long, is to explicitly declare an integer as long. By default, this is an integer, sir. If I give 1 and 2, these are integers. Now, which method is called here? It will always go to this first method, integer method, or method with integer parameters. Then how to call method with long parameters? Then there is a simple solution here. If you want to declare an integer literal as a long, explicitly if you want to make it long, you can suffix it with the small l or capital L. You can suffix as a small l or capital L. This time what happens? This becomes a long parameter. Sorry, long value here. Okay. So this is another important point. If you want to explicitly declare a literal as long, you can suffix that literal with the small l or capital L. Just like how you do for float literals. Okay, maybe for for a change, what I will do is I'll take it as a 2 and 3, just to show that when I say 1 2, you might think that same integer is called. Just to show the difference, I just changed the values here for long literals. It's 2 and 3 here. Okay. Now we have all the 4 methods called here. We have 4 different callers. We know very well which caller is going to call which method. Now just print all the results. The first one I am printing as per the order. First one will make a call to integer method with integer parameters. Second one with the long parameters. Third one with float parameters. Fourth one with the double parameters. Let's run this and see the result here, gentlemen. We have 1 here, and first time val 1 is the minimum here, and the second time 2 is the minimum, third time 1 is the minimum, fourth time 10 is the minimum. It's perfectly giving us results. So this is how we find what's it. We find a minimum of 2 numbers with the overloaded methods, but not every time we use all these methods. When you have methods overloaded, it doesn't mean that you should call all the methods. You choose whichever you need in that situation. Like it's like going to a buffet. There might be so much of food, you cannot eat all that food. You choose only which item you can eat and which you like. That's all. Got it right? So that's the point here. So you got clarity on this, right? On this overloading, no? All of you are good, sir? All of you are good with overloading, polymorphism, and then what else, sir? Compile time polymorphism, all that. Tomorrow we will discuss what is it? We will discuss overriding. Okay, tomorrow, in sense, what I mean on Monday, maybe if possible, I try to plan weekend sessions for Spark. Okay, are you comfortable if we plan on weekends? for Spark. I'll tell. It's not immediate plan. First, I should finish my Python sessions on weekend. Otherwise, it becomes double burden. I will update the timings, no doubt. Probably which are comfortable for everyone. It's not like we don't have odd timings. Usually, I don't plan in the morning, no doubt. We don't have morning sessions. Okay. So you got idea, right? And from here onwards, we'll take more use cases, and you also get more understanding. Okay, got it, right? Okay, sir. Thank you very much. Maybe my small request is, please share these sessions to your friends, and please tell them the importance so that it will be useful to everyone. Okay. The content is really useful. I know, because it's not like I'm not saying because I am teaching, but because we the kind of use cases we are doing, and the kind of analysis we do in the sessions, and your questions sometimes will add more. Yeah, Sandeep, I will do it. You are chasing me at. I already have uploaded one video before this session. One more I will do. Remaining two I will do it today itself, Sandeep. Okay. Okay, sir. Happy weekend. Okay. Have a good day. Stay home. Stay safe. How to write this program in Scala? This is Scala only. This is not Java. Somebody is asking a question here. Okay, this is a Scala program. This is not Java program. I don't know whether you got confused here. Somebody Vijay is asking this. Okay, this is not a Java program. It appears to be Java, but everyone who is attending these sessions, they definitely know this. Might be you can do one thing, Vijay. You can please go through the sessions whatever we have done, and it's uploaded in the YouTube channel. That will give you some basic understanding so that you can follow the remaining sessions. It's okay, Sandeep. No issues. See, you have that interest in learning. I appreciate that. No issues. Okay. Sometimes you should understand this. Don't feel bad. No, I might have some other things occupied. Or I don't remember. The problem is not uploading. You don't remember exactly. Got it right? Okay, guys. Good night.